Hi guys, how's it going? In today's video we're going to finish up section 3.3 with an application with a motion problem. So it tells us that we have a train station, we have one train that leaves the station going 75 kilometers north. So I'm imagining this down here is my number line, and train 1 will be represented with red and train 2 will be represented with green. Alright. So let's start off by monitoring the progress of train 1. So train 1 goes 75 kilometers per hour north. So after 1 hour, it's gone there. After another hour, we've gone up 75 more. So this is 75. And then each of these tick marks represents 25. So after we go up 75 more, we're here at 150. And we could keep tracking that, but now let's go to the green value. Let's go to the green train, which leaves 2 hours later. So after 2 hours has gone by, this train is still smack right here at 0. It hasn't left yet. But let's just say 1 more hour has gone by. Coming back to the red train, 1 more hour has elapsed. This is like hour 3. So hour 3 has gone by, and we go another 75. So now we're, say, here. And remember, we've gone by an hour, and now train 2 has actually began moving. We know that train 2 moves 125 kilometers per hour. So after 1 more hour, train 2 will be right here. So currently, after hour 3, train 1's here, train 2's here. So train 1 has the advantage. And we just kind of keep tracking this. We keep doing this. We keep adding 75. Adding 75 brings us there. And adding 75 once more brings us here. And I'm going to track the green train now again. From here, remember, the green train travels at 125 kilometers per hour, so we need to add 125 again to this number, which leaves us with 250. That puts us there. And then another hour goes by, and then that puts us at 375. So notice it's kind of hard to see because I stacked them on top of each other, but the green and the red both matched up at this value of 375. So after, let's see how many dots it took. After 1, 2, 3, 4, 5 hours from when train 1 left, both trains met. 375 kilometers from the station. So that's what we were trying to find. We were trying to determine how far along the two trains would meet up from the station, and that turns out to be 375 kilometers. So we kind of solved this very experimentally, but what I want to do now is take the time to think about how we would solve it with a couple of linear models. So we can model each of these, we can model the distance of each train with a linear model. So our first linear equation for train 1, so this is our linear equation. This will be a more systematic way of solving these. Our linear equation for train 1 is of the form, we'll say y equals, now we take the slope, which is like the speed, so that's 75 times, let's say t, you could use x if you want, I'm going to use t instead of x, and then that's really it. We were starting at 0, so we have a y-intercept of 0. But for train 2, we have to be a little bit careful. With train 2, remember that train 2 leaves 2 hours later. So what we want to write for that equation is 125 is still the slope. That's still that. But the way that we're going to adjust this, remember that after 2 hours, we want train 2 to have only gone a distance of 0 meters, right? After 2 hours, the train 2 is still sitting there. So what we really need to have is we need to be able to plug in 2 into this function, and we need to get 0. Another way of putting that is that we need to put a t minus 2 here. In other words, we're 2 hours behind, so we have t minus 2. And notice that if we were to plug in 0 for t, or sorry, if we were to plug in 2 for t, we would get 0 here. So that is what we want. Now, what we were trying to find is we were trying to find when these two distances, remember y represents distance, so we want to know when these distances equaled each other. So what we really need now is we need to set these two equal to each other. We have 75t is 125 times t minus 2. We solve this equation by distributing, leaving us with 125t minus 250 and 75t on this side. And then after a little bit more rearranging, say subtracting this from both sides, leaves us with minus 50t equals minus 250, and then so t is just 5 hours. Or in other words, the distance traveled, how far along these have traveled, would be y equals 75 times 5, so 75 times 5, so 75 kilometers per hour times 5 hours would be a total distance of 375 kilometers. So the takeaway from this is that the distance functions are modeled by these linear equations where it's the rate times the time, but just remember that the train 2 had an offset of 2 hours, so we needed to make this t minus 2, and so that way when we went to plug in 2 for t, we would end up getting 0 here, which is what we would want. And after setting these two distance equations equal to each other, these two distance equations, after we set those equal to each other, we can solve for t, which was 5 hours, but what the question was asking for was the number of kilometers, how far from that train station that the two trains would meet, which would be 375 kilometers. So that's the end of this video. I wanted to approach it a more experimental way with this number line first, just to kind of see, like if you were totally stuck, you can still think these things out without too much of a systematic process and figure out the final answer. But the experimental process has its limitations. Like suppose they ended up meeting way further on down the line. You would have had to have done a lot of calculations to get you there. Whereas setting it up with a linear model and just straight away solving is pretty quick. And we got t was 5 hours, 375 kilometers was the final answer. That's the distance from the train station that the two trains met. So that's it for this video, guys. I hope you enjoyed it. And in the next video, we're actually done with chapter 3 now. So the rest of chapter 3 will be more heavily covered in Math 105. So that's it for chapter 3 for us, guys. In the next video, we're going to begin chapter 4, and it's going to be on inequalities. So I hope you guys enjoy the rest of your day, and we'll see you in the next video.